We're going to move to the next speaker, Benilton Carvalho, who is an assistant professor of statistics and advisor to the Dean of Research at the University of Campinas in Brazil. He's also a steering committee member of the Brazilian Initiative on Precision Medicine, which he'll talk about today, and has been developing statistical methods and tools for genomic data analysis. So Benilton, take it away.
Thank you, Heidi. Hope it is fine. I hope that actually I'm finding all of you guys in good shape, in good health. Let me just make sure that I can get to the slide. Just one quick second. There we go. So you guys learned yesterday about the importance of actually having a better understanding of diversity in genomic data. What I want to tell you guys is that this is actually something that plays an important role here in Brazil. We are based in São Paulo State at University of Campinas. And what happens is that BIPMed, the Brazilian Initiative on Precision Medicine, is actually formed by a team of different professionals that are not working exclusively for the initiative. So we have medical doctors who are actually making attendances at the university hospital. And then we have to teach, we have to do a lot of administrative work as well. So what I'm gonna show you guys is actually how we have been dealing during these past few years. It's been quite an amazing ride, to tell you the truth. And what we have got so far, I have to remind you that I need to thank these 4 people here, Dr. Isia, Cristiane, Wellington, and Rodrigo, because without them, I would not have any of the results here to share with you. So this is going to be a presentation where I'm gonna show you some of the findings that we actually got in this past year through the use of strategies that we have been learning along with the GA4GH. Just to remind you guys, BIPMed is a coalition of 5 research centers in São Paulo State. And among these centers, we have specialties of different kinds. We have neuroscience, we have computational science, cell therapy, inflammatory disease, and obesity research centers. Sorry, this does not seem right. Hold on just a little bit. I need to zoom out just to make sure that there we go. I can see the whole slide right now. We also got, at the very beginning, what we had was a genomic database that was shared publicly in terms of pooled data. And it had information about subjects that were not patients. They were what we are calling reference subjects from the Brazilian population. And these databases were distributed were actually obtained through 2 different technologies. We had a bunch of whole exome sequencing and also array data. They were public shared through our system. And back in 2015, we started with the LOVD database using Beacon, and 16, we went to the genomics API. We had a few packages delivered through, produced and delivered through the bioconductor framework. And we also had a Beacon client that was derived using R. Later on 18, what we had was moving towards a cloud environment, improving our web applications, and we had actually a specific request that we were getting clinicians to use the data that we were distributing, and they were finding it slightly more complicated for them to get a better understanding. So what we did, we provided with a new tool for us called BRAVE, the BIPMed Variant Explorer. And in 19, we started looking towards these newer strategies where we could actually do authentication of users and give different access, different levels of access to the data. So our databases have been initially distributed through these LoveD instances. They are databases that are actually getting data from different phenotypes. They not only have data on reference subjects, but also on specific phenotypes. And one tiny detail actually that I would like to share is that most of the traffic that we are getting on those databases are actually coming through the United States and China, and Brazil is appearing only on the 3rd place on that particular ranking. Now, thinking about the Variant Explorer, the reason that we started looking at something like that is because most of the time we would be within a programming language and wanted to query data to do, for example, filtering on variants. I wanted to see, for example, all the variants that were appearing at most 5% of that particular data set. So we implemented that, and it does support multiple data sets and different versions. Now, the thing that is actually making a big difference for us is the fact that this tool is actually transparent to the environments that we are using. So it really doesn't matter if we are, for example, working on a HPC cluster or if we are on the cloud, we can always have access to this particular tool. Now, it does have a specific API that allows us to do different queries to the data that we have stored. And it allows us to, for example, not need anymore the VCF files once the data are imported. These informations are actually required by us to be able to provide reports and do the data analytics on what we have got. So essentially, it has a web application. Let me see if I can get the, there, hold on, winner. So it does have a component that is a web application where people could simply browse through it. And we are working on strategies to do authentication in order to be able to get to individualized data that might be needed during specific points on data analysis. And it does allow you to bring data from Python and R if that's the case that you're running into. Now, this is the visual interface that the browser has. So different types of queries can be placed there, and we could get the results, and we would have some statistics on clinical significance and also on coverage that we have for those particular samples. And later on, what we started looking at is actually the need of a better strategy to do genotype calling on our samples using GA4GH implemented best practice. Now, what we decided to do was to write actually some piece of code that is based on WDL, on WDL and Cromwell, that it does make use of the GATK4 infrastructure, and it allows us to speed up really by a lot the timing that we would get for genotyping per sample on legacy equipment that we have in-house. Now, one of the things that we have been using a lot and we need to improve our use on that is actually on the CRAM files. This has been very useful for us because it does show a lot of compression of the data. And it allows us also to have this fully reproducible and platform independent environment where I can start adding my samples and get the calls either on local machines, on clusters, or on the cloud. Now, that said, we are still on the Beacon network. We are still using the Beacon, despite the fact that we have not upgraded it to the next version yet. So we probably will start doing that sometime early next year. But now, let me just go ahead and focus on one tiny thing and keep you guys on time. We have these two reference data sets. We have the whole exome data, and we have the array data on the subjects that were sampled from the Campinas region. Now, here's one information on these subjects. We have the distribution in terms of the region where those reference individuals came from, despite the fact they are now found in Campinas. Most of them are from the southeast area, and some of them were actually unknown, but we do have tags for those that were coming from the south, north, and northeast. Now, back to the subject yesterday on the importance of knowing and understanding better the diversity on genomic data. What I would like to remind you guys is that our findings during this year that should appear soon on genomic medicine is that if you guys get markers, for example, that are called common markers, let's say they have frequencies greater than 5% on European populations, these markers, some of them, actually about 7,500 of them, are found to be rare in the data set that we have in hand on Brazilian subjects. The other way around also happens. So markers that are called rare on European populations, about 75,000 of them were actually seen as common here on subjects in Brazil. And the same behavior would happen with African populations and American populations, mixed populations in general. So what we have here, for example, for African populations is that the common markers for those set of subjects, we would have about 65,000 of these markers being called rare in subjects that we have here in Campinas. So what that brings us into mind is the fact that if we are making clinical decisions on these subjects, we actually need once more to be very aware of how those markers that our decision were based on behave on the particular population of interest, okay? Now, just to remind you guys of a famous PCA plot, you guys have here the PCAs for exome data and SNP data. I will just focus on the SNP data because it's pretty much reproducible everywhere. We have the corner there with Europeans, African at the left-hand side, Asia at the bottom right, and then mixed American populations here in green. Now, what happens is that the Brazilians are the black dots here. They scattered all over. So there is pretty much a gradient from Europe to Africa in terms of signatures of Brazilian subjects. I want you guys to pay attention. If you guys have a better zoom than what I do, behind the orange dots there are actually two black dots. So those are Brazilian subjects that if we were actually to look at their genome to make clinical decisions, we would actually to be able to understand a lot about the Asian genomics in terms of genomic medicine. The same thing happens here on the left-hand side where we have subjects that are getting really close. And I know that there are some overlaps. I think there are about 10 to 15 subjects that are actually underneath the red dots over there. So that's the same decision. If we were to make clinical decisions based on personalized medicine for those subjects, we would need to be very aware of the African genomic information that is used in precision medicine. So this is the first time that this was observed here in Brazil. And it's actually very important for us to take that into account in this time where we are trying to, or not only trying, we are making it happen very slowly, I know, but we are implementing the personalized medicine infrastructure in the country. Now, one other thing, and I'll save you guys 5 minutes, I'll just skip right to the end, is looking at the ancestry that we have in Brazilian subjects. And again, I'm showing these because all of these was only possible because we were using the strategies that we've been learning actually from the Global Alliance for Genomics and Health. So what we would have in this particular case is that the Brazilian population is actually an admixture of Europeans, Africans, and Native Americans. So in order for us to study a little bit better the local ancestry that Brazilian subjects show, we actually needed also to study a lot of history, right? But again, we got data on this. We got SNP arrays on subjects, on 200 subjects. These subjects were originated from different places in the country. And what we could observe really is that the history books tell us a lot already about the genetics. It tells us that the majority here of the influence that we have on the Brazilian genome, if I may force the use of this expression, is actually European, with a great contribution from Africa, and then some other contributions from the admixed Americans. So this is pretty much what we knew already, but then when we start zooming in on what happens on each chromosome, what we observed was that on chromosome 8, there is a decrease of the European ancestry contribution to the Brazilian genome. And instead, we have Native American ancestry actually peaking on that very same region. So there is this 1 point of deviation on chromosome 8. And we looked at it a little bit closer, looking at the specific genotypes. And what we were able to observe is that there was an inversion polymorphism for some of the subjects. So in red are the inverted ones, and in blue are the non-inverted ones. Anyways, once we started looking at this, we could actually start thinking about the reason of the deviations that we were observing across these subjects. I'll just go straight here and show that to you guys that what we saw in particular is that these deviation on chromosome 8 showed an increased Native American ancestry, probably due to 2 facts. And then these inversion events and recent selection were possibly the reason for these deviations. We also are making a highlight here that this is extremely important for population genomics, in particular due to the fact that events like this are actual confounders for the ancestry inferences that we might need to do in terms of precision medicine. So I'd like to thank all of you guys for having the time to hear me. And that's it. Thank you.